is Unit 7, Lesson 3, and in this lesson we are going to be graphing vertex form of parabolas. This is a review of something that we did in the first unit, but I like to go over this several times to make sure it sinks in because this is the first of the parent function families that we talk about, and if you know how to do this parent function, it makes all the rest of them very, very simple. So the parent function of a quadratic equation is y equals x squared. We're going to graph that over next to this in just a minute so that you can see what the parent function looks like and so that you can see some relationships of that parent function. The vertex form of a parent function is y equals 1 times x minus 0 squared plus 0, because in the parent function, if we were to think about graphing that, if we chose some negatives and some positive numbers and 0 to plug into that, if we plug negative 2 in, we get 4, negative 1 gives me 1, 0 gives us 0, 1 gives us 1, and 2 gives us 4. So if we were to graph that, notice the parent function starts at 0, 0. It will go left 1 up 1, left 2 up 4. And then from 0, 0, it will go right 1 up 1, right 2 up 4. So this is an extremely important pattern when we're dealing with the quadratic equation parent function, and especially when we're dealing with a quadratic function that has an a value of 1. Because if we can write that quadratic function with an a value of 1 in vertex form, then we can automatically figure out what h and k are, and we automatically know that the thickness of that graph is the same thickness as the parent function. And that, again, is when the a value is 1. Now, to quickly review, hk represents the vertex of our quadratic function. Now, we said that since there's a minus here, that whatever number you have inside there, it's going to go in the direction that is opposite of what you would think. Now, remember, it's paired with the x, so the number on the inside tells us whether to go right or left. If there's a minus inside, we go right. If there's a plus inside, we go left. So it's the opposite direction that you would think. And then on the outside, the k value tells us whether to go up or down in the same direction that you would think. So a positive, it goes up, and a negative would go down. How do we know which one represents right, left, which one represents up, down? Well, if our vertex is h, k, h is the x coordinate of the vertex. The x always tells us whether to go right or left. The k is the y coordinate of the vertex, and the y always tells us whether to go up or down. So that's how we know where the vertex would begin. Then we also talked about the a value earlier. If a is negative, it flips parabola upside down. If a is a fraction between 1 and negative 1, then it will be a wide graph. It will be wider than normal. And if a is a number whose absolute value is greater than 1, then the function will be more narrow. Now, as far as any a value being different than 1 or negative 1, we will not graph those by hand. We will do those on Desmos and look at them. But we should know just basic information about the a, like if it's a fraction between 1 and negative 1, it makes the graph wide. If it's a number whose absolute value is greater than 1, then it makes the parabola very narrow. As long as our quadratic function is in graphing or vertex form like this, we can always find the vertex very easily. Okay, so I have graphed the parent function. Notice the parent function, it starts at the origin 0, 0, so it's here. And then we said that from the origin, or from the vertex, we would go right 1 up 1, right 2 up 4, left 1 up 1, left 2 up 4. And as long as a is 1 or negative 1, we're going to follow that pattern. Okay, so now, if I were to give you something in vertex form, like y equals 1 times x minus 3 squared minus 2. Well, if you look at that, in this one, this minus sign tells me we're moving right 3 from the origin, right 3 and down 2. So my vertex is 3, negative 2. So my graph for this quadratic equation, with a being 1, we know since a is 1, it opens up. The vertex is at 3, -2, so I go right 3, down 2, and then from there I go right 1, up 1, right 2, up 4. Left 1, up 1, left 2, up 4 to get my transformed quadratic function. And you can see that it's the same thickness, the same width, it's just moved right 3, down 2. Here's another one that I'm going to graph. Notice the a value is negative here, so that means it's going to go down. The vertex is going to be left 4, or -4, down 3. So my vertex from the origin goes left 4, down 3, so it's right here. And then since this one goes down, instead of going right 1, up 1, I'm going to follow the same pattern, but it's going right 1, down 1, right 2, down 4, left 1, down 1, left 2, down 4, to give me this quadratic function. Again, same thickness as the parent function, but this one is reflected over and moved left, transformed or translated left 4, down 3. Now, thinking about this, if we think about the quadratic roots with this equation, if I were to ask you to find the roots of this equation, where are they? Where does it cross the x-axis? Hopefully you're looking at that saying, well, it doesn't cross the x-axis. And in Unit 6, we learned when we were dealing with complex roots that the graph, when we learned about the discriminant, we said that the graph, when we have complex roots, is going to be never crossing the x-axis. It will either be below it if a is negative, or above it, never crossing if a is positive. And we have that situation here. So what I want to do is I want to take that equation that we were talking about, and I want to look into finding the roots of that equation to see if that in case is the fact here. So in this function, we know that the vertex is -4, -3, and we could put this in graphing form if we just FOIL that. So x plus 4 times x plus 4, I'm going to keep the negative, that's x squared plus 8x plus 16, and I've got the -3. I distribute the minus sign, so that's -x squared minus 8x minus 16 minus 3. So y equals -x squared minus 8x minus 19. And what I'm trying to do here, for you, is try to show you the relationship between negative discriminants, numbers that are negative underneath the radical, and what happens with the graph. Because we're eventually going to get to the point where we want to, in order to graph quadratic equations, we're going to want to find the roots, we're going to want to find the y-intercepts, we're going to want to find all kinds of stuff to be able to graph it. And vertex is one of the things that we're going to be finding. To find the vertex, we're going to want it to be in vertex form. But to find the roots, we're going to want it to be in standard form. So going back and forth between these two forms becomes very important for us. So with this one, if I'm trying to find the roots, I'm just going to use the quadratic formula. -8, or -b, plus or minus the square root of b squared, minus 4 times a times c, all over 2a. So I have 8 plus or minus the square root of 64 minus 76, still over -2. So that would be 8 plus or minus the square root of -12 over -2. Well, if I simplify that, that is 8 plus or minus 2i square root of 3 all over -2, or -4 plus or minus I square root of 3. So -4 plus or minus I square root of 3, those are two complex roots. So if you think about that, that matches what we had said about the graph when the discriminant ends up being a negative number. Okay, we've got the graph here going underneath the x-axis and never crossing the x-axis, meaning our roots are imaginary. So that shows you how that works. So now let's talk about a quadratic equation that is in standard form and how we would go about graphing that. We can't go by the vertex here because it's not in vertex form. If it were in vertex form, or if we wanted to do it that way, we would have to convert this to vertex form. So we will do that in a minute once I'm showing you some different things. But for now, I want to approach this one by, let's find the roots first and then go from there. Okay, well, first of all, if I'm going to find the roots, I need to set this thing equal to 0. So 0 equals x squared plus x minus 6. The next thing I need to do is factor. What factors of 6 subtract to give you 1? Well, that would be 3 and 2. That would be a plus 3 and a minus 2. And so if I set each of those roots equal to 0, I have x equals negative 3 and x equals 2. So we need to understand what that means. Roots are your x-intercepts. They are your solutions to the quadratic equation. They are also called zeros. So your roots are where this graph is going to cross the x-axis. So it crosses the x-axis at negative 3 and at 2. Okay, now, think about it. Your a value is the number in front of the x squared. This a value is 1. So we know that this one, since the a value is 1, is going to have the same shape that the parent function did. Wherever the vertex is, you go right 1 up 1, right 2 up 4. Left 1 up 1, left 2 up 4. So if you know that, and these are the roots, and we also know that 1 is the a value, and it's a positive 1. So don't we also know that the vertex has to be down here somewhere because it has to go up, okay? Another thing that we also know is that the y-intercept is the c value here. Now, how do we know that? Well, isn't the y-intercept the point where the x coordinate is 0? So if I want to plug 0 in for both of these x's, wouldn't I get negative 6? So my y-intercept, and when it's in standard form, when your equation is in standard form, this number down here is always going to be your y-intercept, because if you think about it, when you plug 0 into the other terms, they all cancel out. So the intercept here is negative 6. So negative 6 is my intercept. So it's right here. And so it's going to go through that somewhere. We just don't know where the vertex is. Well, if I want to find the vertex of this equation, I could just complete the square and figure out what that is. I'm going to do that right here. So I've got x squared plus x. I group those two, leave a little space, and put the minus 6. Half of 1 is 1/2, and 1/2 squared is 1/4. So if I add 1/4 here, I'm multiplying it by 1. I'm going to subtract 1/4 out here. So then I've got x plus 1/2 squared minus 6 and 1/4. So that's what my vertex form is. So my vertex here is negative 1/2, negative 6 and 1/4. So negative 1/2, negative 6 and 1/4 is about right there. Now, if you think about that, whenever we have a parabola, if you think about the nature of a parabola, if the vertex is the lowest or the highest point, there's something called an axis of symmetry that goes through that vertex point. And that axis of symmetry makes every point on the parabola equidistant to the point on the other side. So this point here is the same distance to the center, or to the axis of symmetry, as this point is. This point is the same distance to the axis of symmetry as this point over here. So parabolas are symmetrical. So if you think about that, if negative 1/2 is our center, well, that's 1, 2 1/2 from that root, and this one is 1, 2 1/2 from the other root. So it is symmetrical. So if this is 1/2 from the vertex, then the other half on the other side is also on the vertex. And in your work, when you're doing these on the computer, on different programs, they're usually, when they ask you to graph a parabola, going to ask you for at least 5 points. Usually they're going to want the root, they're going to want the y-intercept, they're going to want the vertex, and they're going to want one other point. Well, the easiest point to find is the one symmetrical to that y-intercept, if you don't have it already in a different form. So if I graph that, my parabola looks something like that. So let's say that they give us directions to graph this quadratic on a coordinate system, and we want at least 5 points. We want to know what the roots are, we want you to graph the roots, we want you to graph the vertex, and we want you to graph the y-intercept. And let's suppose they give you something like this, okay? Well, that's not in either form. It's not in vertex form and it's not in standard form. So it looks a little bit weird. But what you want to realize here is, in order to find the roots of a quadratic equation, isn't all you have to do set the quadratic equation equal to 0? So if we set this equal to 0, isn't it already factored? In other words, I could FOIL all this and put it all together and end up with standard form, but then to find the roots, wouldn't I have to go backwards and do it all again? So what you need to recognize here is they have given you this equation in factored form. And to find the roots when the equation is in factored form, all you have to do is set those factors equal to 0. Now, the -2, when I divide both sides by -2, it drops out. We've got 0 equals x plus 5 times x minus 8. That's something a lot of students forget that. They forget that it can be dropped out, and it really doesn't affect anything, at least when we're finding our roots. Now, we know our a value is going to be -2. So if you think about it, is this one going to be going in an upward direction or a downward direction? Well, you should know, but we'll talk about that in a minute. The roots here, my roots, or the points where it crosses the x-axis, are at x equals -5 and x equals 8. So I'm going to put a dot on -5 and on 8. Next, I think I'm going to convert that to vertex form so that I can maybe find my vertex. It might be a good idea too to try to find the y-intercept. So if I think about that, the easiest way to find the y-intercept, we found everything we could by the factored form. So let's go ahead and FOIL that together. -2x minus 10 times x minus 8 plus 16x minus 10x would be a plus 6x. And then that's a positive 80. So now if we look at this, didn't we say that the y-intercept here is what we get when we plug 0 in for the x values? So doesn't that mean that the y-intercept is going to be 80 here? Okay, well, my graph doesn't go up high enough, so I know that it's going to go way up there and cross the axis at 80. Okay. Another thing I could do is I could get this in vertex form. So if I put it in vertex form, and this one's kind of a strange one because we're not going to be able to really graph this one by hand. You could graph it on Desmos and look at it and see what it looks like. So if I put this in vertex form, I'm going to group the first two. I'm going to take out a -2. I've got x squared minus 3x. I keep the plus 80. Half of 3 is 3/2, and 3/2 squared is 9/4. So if I've multiplied this by -2, that means I've really subtracted a 9/2 there, so I need to add a 9/2 here. And so my vertex form is -2 times x minus 3/2 squared plus 84.5. So my vertex is 3/2, 84.5. And if you think about that, since we said that our y-intercept was going to be at 80, it makes sense that 84.5 are a little bit taller than where it's going to cross the x-axis. But again, you can graph this one on Desmos and be able to look at it and see what's happening. So just to recap real quick, it's going to be easier to find your roots and your y-intercept from standard form of the quadratic equation. It's going to be easiest to find your vertex and whether the function is going up or down using your vertex form of the equation. So both of the forms have some really significant uses for them. So it's important to know both forms and how they relate to the graph.